2016 November past paper. So the basic scales as shown in the image use specific items to weigh fruit and vegetables at a market. The handler uses batteries and metal weights. All right. So as shown in the diagram, the combined weight of two metal weights and three batteries is 305 grams. One metal weight measures 100 grams. Okay. One measures 100 grams. What is the question? Using the information from the diagram, find the weight of one battery. Okay. So looking at the diagram above, we can say that three batteries plus two metals are equal to 305. And we know that one metal weight is 100 grams. So I can say that 3B represents batteries plus 2 times 100 equals 305, 305. 3B equals 305 minus 200. 3 batteries equals 105 grams, and one battery equals 105 divided by 3 grams. So if we were to use the calculator and find the value of one battery, we would get an answer of 35 grams. Does that make sense?
Yeah.
So this is something that had to be done using mathematical calculations. Most students would have gotten the right answer as well, but you see the mistake they would have done was they wouldn't have used mathematical calculations to help them. So weight of one battery is 35 grams. Then part 2 says 10 similar sized tomatoes weigh the same as 3 metal weights and 2 batteries. Calculate the weight in grams of one tomato. Alright, so let's just solve the question here. 10 tomatoes are equal to the weight of 3 metals and 2 batteries. In place of M metal weights, I can substitute 100. Why? Because one metal plate is of 100 grams and one battery is of 35 grams. So two batteries, I'll just multiply it by 35. Oops. So what am I getting as a result? 10 tomatoes are equal to 300 plus 70. This is equal to 10 tomatoes equals to 370, and one tomato is going to be equal to 370 divided by 10, which is of 37. Alright, so the mass of one tomato would be 37 grams. So this is how we are supposed to find the mass of uh, a tomato. Alright, so essentially what are we doing is that we are using the idea of simultaneous equations. Alright, I hope this makes sense.
Yep.
Great. Write it and tell me once you're done.
I wrote it down.
All right. Most of the time, students tend to, waste their time by reading each and every information. My idea is that whenever you see a question that looks like this, first try to look at part A and see whether or not is a specific part dependent on the information that has been provided or not. Sometimes what happens is that a specific set of paragraphs are given and they contain some numerical values and we'll solve such questions. Only that part needs to be read. Now realistically we don't have much of information here, so we can directly jump on to question number 2, part A. Write down the area of the section labeled D. Now that's not a difficult question. The section labeled D has a width of 3 and a length of 4. So 3 multiplied by 4 gives us an answer of 12 meters squared. Very important that you put the values. The units. If you don't put the units, you're going to miss that one mark. All right. Then it says, two-part B says, determine the value of the length labeled A. So you have been told that the area of this region is 24 meters squared. The length of this part is essentially 4 meters. So A should be a product of 4 and 24, a quotient of 4 and 24. So A multiplied by 4 should be equal to 24. A should be equal to 24 divided by 4, which becomes 6 meters squared. Sorry, it's not 6 meters squared, 6 meters simply. The length is 6 meters. Make sense? Okay. Then we have 2 part C. Write down an expression for the total um, area of the rectangle in terms of the length B. Okay. I know that the formula for the rectangle or area of a rectangle is supposed to be length multiplied by width. All right. So, realistically speaking, the value of A has been given as 6, which is the length, a part of the length, and 3 is the remaining part of it. So, I can say that 6 plus 3 essentially equals to 9. So, the length is of 9. The width is going to be the sum of 4 and B. 4 plus B. So in terms of B, whenever it says in terms of B, find the value or an expression of something. So it means B should be a part of that expression, right? So if I want to apply the formula of length times width, I can write it as 9 multiplied by 4 plus B. And this can be further simplified as well. 9 times 4 is 36 and 9 times B is 9B. So I'm getting an answer of 36 plus 9B. I hope this is clear to you.
Yep.
Great. The total area is 63 meters squared. Determine the value of the length of B and areas F and E. Let me just bring that, take a screenshot and let me just bring that up. Okay. This has been the area that has been given, the total area. So let's check this out. Did we wait a second? Wait a second. We were given, it says, write down an expression of the total area of the rectangle in terms of length of B. So I know that 36 plus 9B. This is something that we had calculated already in the previous part, right? 36 plus 9B should be equal to 63. That was the expression. So let me find the value of B first. So 9B equals 63 minus 36. 9B equals to 27. B equals 27 divided by 9, and the value becomes positive 3. So we know that the value of B is positive 3. Now how to find the value of E in this case? E is of course going to be the product of its length and its width. So E is basically a square. So the value of E is 3 times 3, which becomes 9 meters squared. And the value of F is the product of its length and its width again. So 6 times 3, that becomes 18 meters squared. Alright, so this is going to be our approach to find the right answer. Tell me once you're done.
I wrote this down.
Okay, then we have part 2E. Um, it says the express the area of the land as a quadratic equation in x and hence find the value of x. 5 mark question. All right. So the area of this entire value is supposed to be 3 plus x multiplied by 3 plus x is going to be the length and the width is going to be x plus 2. So 3 plus x, 3 multiplied by x gives me 3x, and 3 multiplied by 2 gives me 6. X multiplied by x gives me x squared, and x multiplied by 2 gives me 2x. So I have an equation that's written as x squared plus 5x plus 6. Alright, now wait a second. Am I doing it correct? Yeah, I think I'm doing it correct. F3x plus 6. Yeah, and the entire value of it is essentially equal to 210. This is just what I had to verify. So I can say that the equation of the line becomes, sorry, not the equation of the line, the equation of this quadratic function becomes x squared plus 5x. 6 minus 210 becomes minus 204. That is equal to 0. Okay. Now comes the tricky part. How do you find the roots of x, essentially the values of x, especially in this case when we have a big number as 204 present in front of us? So first things first, let's try to make the factors of 204. 204 can be written as 102 times 2. It can be written as 51 times 4. It can be written as um, 34 times 6. And what else? No, not divided by 8. Yeah, divided by 12. It can be written as 17 multiplied by 12. Okay, so these are the factors of 204 that we understand how to make factors, right? So 17 and 12 seem like a suitable option. So I can write this as x squared plus 17x minus 12x minus 204. X is common, and within the bracket I have x plus 17. Minus 12 is common, and within the bracket I have x plus 17 again. So I have two values, x minus 12 and x plus 17, and the real values of x that I should be getting are x equals to 12 and x equals to negative 7. Now, can you tell me what value am I going to consider for x, considering I have two options? Yes, I have
Could you
these
repeat them?
two options, x equals to 12 and x equals to 17. Which one of them seem like a more logical option in this case? Since it says hence find the value of x, one value of x needs to be considered. So what do you think should be considered in this case?
I'm not sure. Maybe 12?
Yeah, 12. Because x is representing a length, right?
Yep.
A length cannot be negative. So if anyone was to write x equals negative 17, they would have lost 1 mark. They would have gotten the working mark for the working, but of course they would have gotten 4 out of 5 because a length cannot be. When it says find the value of x, it should have been the correct value. I hope this is clear and this makes complete sense.
Yeah.
Great. So let's move forward. The grades of 20 students in mathematics are shown in the table and the pictogram below. Statistics questions, once again, practice is required. Write down the modal grade. Modal is derived from the word most repeated value. This is derived from the word mode, right? So we can see the largest frequency or the number of students being in grade 5, right? So
Yep.
our answer is going to be 5. Simple as that. 3 part B says show that the arithmetic mean grade of the students in mathematics is 4.7. Okay, for the arithmetic mean, I explained the formula that was frequency multiplied by um, class, we write it down in a better way, however, even written, should be divided by the total number of 20, which is in our case is 20. So the frequency of students. Now, logically have a look. In first grade, there are 0 students that take math. All right. So I can say 0 times 1 plus. In second grade, there is only one student. 2 times 1 plus. 3 times 4, because in third grade there are 4 students, and in the fourth grade there are 3 students. So 4 times 3 plus. 5 times 6 plus. 6 times 4 plus. 7 times 2. The entirety of this is going to be divided by the total number of students, that is 20. So if I was to do this manually, you can use a calculator. Ideally, you should use a calculator. So I can say 2 plus 12 plus 12 plus 30 plus 24 plus 14. All of this is divided by 20. 24 plus 2 is 26, plus 30 is 56, 56 plus 24 is 80, 80 plus 14 is 94, divided by 20. And yes, 94 divided by 20 is the same thing as 47 divided by 10, which is equal to 4.7. This makes complete sense.
Yep.
Okay, so in roughly 23 minutes, we are done with 23 marks. Then it says, determine the median grade. So the median is found in a very fascinating manner. We, the method to solve a median in such case is that we delete one from the start and one from the end. So one is removed from here, then one from here. Two, then two. Three, three. Four, four. Five, five. Six, six. Seven, seven. Eight, eight. Nine, nine. And basically there are two numbers in between. So what is numbers in between? So what essentially happens is that those two numbers are basically taken a median from them. So both of these two numbers are added together and then divided by 2. But since both the numbers are 5, so I know that 5 plus 5 over 2 essentially becomes 10 over 2, which becomes 5 again. So the median is going to be considered as 5. Does that make sense?
Yep.
Okay. A student is selected at random from the 20 students. Determine the probability that the student achieved a grade of 6 or more. Oh, these are MYP students type questions. Oh, my bad. I thought they belong to grade 1, grade 2, and stuff like that. Okay. Okay. So, a student is selected at random from the 20 students. Determine the probability that the student achieved a grade of 6 or more. So, 6 or more. It means that basically the students that got 6, there were a total of 4 students. The students who got 7 are 2 students. So 4 plus 2 over 20, that becomes 6 over 20. May the MYP results be the opposite of it. So that becomes 3 over 10, or simply 0 0.3. Make sense?
Yep.
Okay. The grades of these 20 students in physics are shown in the table and pictogram below. Okay. The students achieving a grade of 6 or more in mathematics and physics will be selected to participate in a competition. Nice. Find the probability that a randomly selected student will participate in the competition. Now, getting the probability of getting 6 or more in math was 0.3, or 6 over 20, or 3 over 10. Fancy ways of writing the same thing. The probability of getting 6 or more in physics is relatively higher. How? A bit higher, not extremely high. 5 students are getting 6 or more, 3 students are getting 7. So, here the probability is simply going to be 8 over 20. Now, it says that the students that are getting these grades are the ones that are going to be participating in some sort of an Olympiad or a competition, right? So, the total probability, it can be calculated by 6 over 20 multiplied by 8 over 20. So if you were to solve it, oops, I am going to get an answer of 3 over 25. So if there are 25 students uh, who took both physics and mathematics, and um, and if they will have to participate in that specific competition, the probability of them is going to be 3 over 25. Make sense?
Yep.
Oh, let's move forward. Let me just pull this down a bit. Circle theorems, we'll do this at the end, later on. This is not right, something that you need right now. Okay, a lot of numericals here. An engineer is examining a weak bridge from a safe distance. In order to make a calculation for the height of the bridge to the ground vertically below, she uses a measuring instrument called a theodolite that allows her to measure angles accurately. The theodolite is set at a height of 1.2 meters. It is placed 57.25 meters to the nearest centimeter from the point A at the bottom of the bridge. The angle of elevation from the horizontal to the top of the arch at B is measured at. Okay, the information is from the animation below. Okay, so the vertical distance is of 57.25, all right, and the theodolite has a height of 1.2 meters, and a part of it has an angle of depression, in fact, an angle of elevation of 22 degrees from the top of the bridge. Fascinating. So, what is the question actually asking us? We know this, we don't have to memorize it. Okay, thank you for magnifying it, that works. The measurements are modeled in the diagram below, which is a side view of the bridge. Okay. Calculate the height from the top of the bridge to the ground vertically below at A to the nearest centimeter. Nice, that's not a difficult question. Essentially, this height is something that we have to calculate, right? And all right, so considering the idea that this length is also going to be, oops, 57.25 meters, I want to find the value of this height first. And then whatever value I get, I'm just going to add 1.2 to it. So let's understand the trigonometric ratios. This 57.25 will be considered the base, this will be considered the hypotenuse, and this will be considered the perpendicular. So I want to find the perpendicular. I have been given the base. Which trigonometric identity links the base and perpendicular? It's going to be tan, right? So
Yep.
tan of 57.25 should be equal to perpendicular. Oh, no, 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 sorry, sorry, sorry. Tan of 22. My bad, my bad, my bad. Should be equal to 57.25. Can you calculate the value of the perpendicular length? I don't know what's wrong with my calculator. G, what do we get?
It's not really loading.
Oh, okay, okay, that's fine, that's fine. Do you have a scientific calculator or do you use Desmos? Okay, wait, let me get a new calculator. A different one. I'm getting an answer of, in this case, I'm getting an answer of 23.13. Okay,
Yep.
and I have to add 1.2 to it because this length is of 1.2. So if we were to add both of this together, plus 1.2, I would get an answer of 24.33. Alright, that's how we'll find the right answer. Is it clear?
Yep.
Great. Calculate the height from the top of the bridge at B to the ground vertically below at. Okay, okay, sorry, sorry. We're already done with that. What's wrong? Okay. What are we being told about the airport? Something. You will interpret information to discuss the sustainability of a proposed airport development. We are developing an airport right now. That's great. The number of jobs at Hong Kong International Airport was 65,000 in 2013. Use the equation of the line of best fit from tab 1 to estimate the number of passengers passing through the airport. Round your answer to the nearest million. So, in 2013, we have been given a value of somewhere around here. But we have to be certain, right? Now, certainty is only going to be apparent through an equation, not through a rough estimate. We can see that the answer should be somewhere around, somewhere, you know, between 50 and 60, maybe somewhere around 55 million. Once again, we are not sure, but we have the equation present with us. Y equals 12 to what 2110x minus 52,880. Now, in this case, what do? This is the y-axis and this is the x-axis. Even if you do not understand coordinate geometry, this question can still be solved. That's the best part about coordinate geometry. Even if you just look at the axis, it says estimate the number of passengers passing through, which means you have to find this value, and you almost have been given this value, right? So I can say that I'll consider y as 65,000. I'll consider y as 65,000 plus 52,818 equals 2110x. I have the value of y, through that I want to find the value of x. That's what I essentially have to do. So if I was to find the value of x, I would simply make x the subject of the equation. 65,000 minus 52,818 should be divided by 2,110. This gives me an answer of exactly 5.733. Wait a second, am I doing something wrong? Oh, this should be added. This should be added. My bad. Should be plus. So that gives me the answer of 55.83. That's the value of x. So essentially, looking at this, roughly 55 million, 55.83 million passengers had traveled that year. So I can say that the answer should be 56 million. Make sense?
Yep.
Okay. That's the best part about coordinate geometry. Even I know, like, you haven't studied coordinate geometry, but only looking at the graphs, if the table is given, then we can solve the question easily. This is tab 2, okay, and this is tab 3. The actual number of passengers through Hong Kong International Airport was 68,488,000. Calculate the percentage error you of your rounded answer from part A. So basically, and have a look. The equation has already been given to you. You don't even have to work for finding the percentage error value. So we calculated that the our answer was roughly 56 million, right? So let's write 56 million minus actual value was of, apparently being said, 68 million 488,000, and that is supposed to be divided by the actual value that we had calculated was, in fact, no, the actual value that was 68 million 488,000, and this entirety of this is supposed to be divided by 100. That's going to yield our perfect answer even without knowing the concept. Now, our percentage error was of minus 18%. But of course, a percentage cannot be minus 18 in minus. But why is it in minus in this case? Because in reality, the answer that we calculated using the graph, using the line, was not accurate, right? Basically, the line was not accurate. It was not our answer's fault. The reality was that the line that we used was just not entirely accurate. So, um, that's the reason why when we are solving for the answer, we are getting an answer of negative 18%. But if we have to write an answer, we can simply write this as 18%. Does that make sense? Free of cost six numbers. The previous part and this part as well. According to economic predictions, 1 million more passengers through the airport would generate approximately 2,000 more jobs. Justify how the line of best fit in tab 1 supports this claim. What is the claim? 1 million more passengers would generate approximately 2,000 more jobs. Tab 1. Hmm. Okay. So look, 10 million passengers would support 20,000 jobs. 10 million, 20,000. So agar if we take the ratios, wait a second, have I, yeah, I have started the recording again. If we take it from the ratios perspective, so isn't 1 million going to support 2,000? Because essentially when 10 is divided by 10, I get an answer of 1. And when 20,000 is divided by 10, I get answer of 2,000, right? So our claim is being supported, right? Makes sense?
Yep.
Great. So I can say that 10 million jobs generate, oh sorry, 10 million passengers generate 20,000 jobs. Hence, or so, 1 million can generate 2,000 jobs. The airport runway data for 2013 in tab 2 shows an exponential relationship between the longest airport runway length R in kilometers and the number of passengers X through the airport in millions, modeled by the equation. Okay, that was some good information. The longest runway length at Motu Mut Airport in Bora Bora is 1.5 kilometers. That's a funny name. Use the equation in tab to determine the number of passengers X through Motu Mute Airport to the nearest million. Where would this place even be? Okay. Determine the total number of passengers X. So this is the equation from tab 2 that has been given to us. 0.7 multiplied by 3 raised to the power of r. So I can say that in order to find this value, I must substitute the value of runway length. R is basically the runway length in kilometers, right? And X is the number of passengers. So I can say 0.7 should be multiplied with 3. That should be raised to a power of 1.5. So solving this, I would get an answer of 3.637. And that, if it's rounded to the nearest million, that is roughly going to be 4 million. Make sense? You just have to substitute the value, nothing else. Let me even check where is this Motu Mute airport. So let's continue. Here is a map for a proposed airport development. A measurement tool is provided if required. Okay, so what do we have in this case? So basically, the local government claims that the airport development will create around 18,000 jobs. You should write a report in which you should discuss the claim made by the local government. Your report will be assessed on the mathematical evidence you provide in your discussion, and you should consider the future of the proposed airport using the data provided in the tabs. In your answer, you should identify the relevant mathematical information for the opportunities available by the proposed airport, make appropriate calculations to provide evidence to support your report, consider the accuracy of your predictions, and comment on the sustainability. Right, we'll just do that. Okay, so looking at the information that has been provided to us, we can definitely understand a few things. First things first, the equation that we had was y equals to 2110x minus 52,880. Okay, and the local government claims that the proposed, airport development creates around 18,000 jobs. And this is the mathematical calculation which will be done using the line of best fit. Okay, and the area of the proposed site, of course. Now, looking at the information that was already provided to us in the uh, previous tabs, we can come to a few conclusions. This was the runway, this is the number of passenger seats and aircrafts. All right, great. So let's talk about the mathematical evidence and calculations. So let's say they're talking about 18,000 jobs, right? How many jobs? 18,000 jobs. So I can say that 18,000 is equal to 2,110x minus 52,818. So in order to make x the subject of equation, I get an answer of 70,818 divided by 2,110. Okay, this gives me an answer of 33 point roughly 33.56 million passengers. Okay, now let's talk about the runway length. What should be the runway length in order to handle the amount of passengers? This was the equation, x equals 0.7 multiplied by 3 raised to the power of r. So 33.56 equals 0.7 multiplied by 3 raised to the power of r. 3 raised to the power of r equals 33.56 divided by 0.7, which becomes, um, wait a second, 47.94. So 3 raised to the power of r should be equal to 47.9. Alright, here comes the tricky part. Now once again, logs are directly not in the standard syllabus like this. So the extended syllabus students will be able to solve it using the ln rule. However, extended standard students won't be able to do that. So for us, we'll have to apply the trial and error method. Let's consider a few values for r. I know that if r equals to 3, that becomes 3 raised to the power of 3. That gives me an answer of 27. And if r equals to 4, so that gives me an answer of 81. Now, I know that the value of r should be between 3 and 4. So let's try the ideal value of 3.5. Okay, if we were to write 3 raised to the power of 3.5, we get an answer of 46.7, but we just have to increase it to 47.9. Let's write 3.55. So when r equals 3.55, we get 49.4. Now we know it should be between both of them. So let's try 3.52. Okay, so when we try r equals to 3.52, we get an answer that is perhaps the closest as of yet, 47.8. And if we try 3.53, we get 48.33. So let's consider the value of r as 3.52, and let's erase all of these values because logs are not directly into your syllabus, so it's difficult for me to teach it to standard student. For the extended syllabus students who are watching this, they can solve it directly on their calculator through this method. Ln multiplied by 3 raised to the power of r should be equal to ln multiplied by 47.94. And since r is the power here it becomes multiplied with ln 3 equals ln for 47.94, and r equals ln of 47.94 divided by ln of 3. Now this is for the extended syllabus students. Of course, the standard ones won't be able to solve it. So what value of r do we get? We're going to get somewhere around, in that case, 47.94 divided by ln of 3. Oops. I'm getting an answer of 3.522. So yeah, we're going to select 3.5. Okay, so we have the value of r. That's the calculations part. And some serious internet issues is what I'm having. All right. Now, the runway should be at least 3.52 kilometers. Okay, 3.52 kilometers. So comparing this against the provided map scale, I can say that the site boundary is large enough to construct a standard major international runway. Okay, according to the plan that has been given by a local government. So, assuming all of the conditions are fulfilled, I can say this hand on heart that um, calculating for 33.6 million passengers, it extends beyond some of the original data ranges. Okay, so what about, let's talk about the sustainability. Our accuracy has been done, relevant mathematical information has been done, appropriate calculations are done. Let's talk about the sustainability. Now, look, there are some pros and there are some cons. The pros are, let me write it as plus and the minus. The pros are 18,000 jobs, economic sustainability or economic boost to local economy. The problem is that the site that has been chosen, you see, around it there are many, there is a river, there is a forest, or if not a forest, at least some greenery. So, environmental degradation. And we can talk about the carbon emissions, we can talk about the runoff into the surrounding rivers, we can talk about the noise pollution. Okay, carbon emissions and habitat destruction, lifestyle changes and stuff like that. So I hope this all makes sense. Oh my god, there is still question number 7. Let's solve question 7. Okay, give me a second, let me just drink some water. We'll solve this question. Okay, so area is pi r square, that's pi times 65 squared. So if we solve it, we get an answer of, and in terms of pi, so that becomes divided by pi, 4225 pi. Great. The wind turbine efficient power PE in watts is calculated as about 45% of its available power PA. This is calculated by the formula PE equals 0.45 PA, where PA equals 0.6 AU. U is basically the wind speed in meters per second, and A is the area of the circle covered by the motors as they turn. Okay. Calculate to the nearest kilowatt the maximum efficient power, which is supplied from a maximum wind speed of 0 of 30 meters per second. Sure. So I know that PA is given as 0.6 multiplied by AU cube, and PE is equal to 0.45 multiplied by PA, where it has been given to us, right? So I can say that PE is essentially the same thing as 0.45 multiplied by zero point 0.6, which becomes, I can write it like this: 0.45 multiplied by zero point 0.6 AU cube. So 0.45 multiplied by zero point 0.6 gives me the answer of 0.27 AU cube. So the value of A was founded off as 4,225 pi, and the value of U is 30. So 0.27 multiplied by A of 4,225 pi multiplied by U of 30 cube. I'm getting a huge answer. Um, it says find the answer in kilowatt, right? So it says 9676183.13. This would be the answer, I suppose, in watt, if I'm not wrong. Yeah. So if it has to be founded in the form of kilowatt, that should be divided by 1,000. So that becomes 96,761 kilowatt. All right. Long questions, man. These 2016 papers were like mentally exhausting. I can't even imagine what the students had gone through. Show that the radius of the circular zone, uh, turning zone needed for wind turbine is 325. I know that what we have been given is the turning zone distance between towers, and it says that it is 5 times the diameter of the rotors D, and there is uh, a rotor diameter of 130 meters. So I can say that 5 times D equals 130. No, in fact, no, 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 no. Sorry, sorry, sorry. 5 should be multiplied by D, and D equals to 130, right? So that gives me the answer of 650. And since, of course, we are supposed to find the radius zone, and we are supposed to find the radius of that circular zone, so that needs to be divided by 2. So that becomes 325. All right. Let me see if there is anything else that needs to be considered. Not really. It doesn't seem like that. Okay. Oops. My goodness. Identify a strategy for the most efficient wind turbine arrangement. Determine the maximum number of wind turbines that can fit inside. So let's first understand what's the total available land. The parameters that have been given to us are 4,000 multiplied by 1800. So if we were to solve it, we get an answer of 7200,000, 7,200,000 or 7.2 million. Okay. We have been given the turning zone diameter of 650 meters. We have the wind speed of 30 meters per second. We have the rotor diameter of 130 meters. Okay. Now let's start some calculations. The maximum number of wind turbines to maximize power without, you know, aerodynamic interference, you can say, the non-overlapping circular turning zones have a diameter of 650 meters. They must fit inside this boundary. They must fit inside the boundary. So along the length of 400 meters, let's try to understand this through the columns. 4,000 divided by the rotor turbine turning zone diameter of 650 gives me an answer of 4,000 divided by 650 gives me, wait, 6.1538. Let me just label this as 6 turbines, because you cannot have 6.15 turbines, right? And you cannot have 7 turbines either. And focusing on the column, so you have a total dimension of 1800 meters. Dividing that by 650, you can have 2 turbines at max. That's along the width. So if we were to multiply these both values, the maximum number of turbines you can ideally have is 12 turbines. Okay, so we are done with this, and we're done with this. Then it asks about estimate the maximum efficient power output. Oh my god. Hmm. Look, there is the rotor area, which is of 130, and its diameter is of 65, right? So if we want to find the rotor area completely, that's pi multiplied by 65 squared. That becomes 4,225 pi, which is essentially 13,273.3 meters squared. Alright, now we have to talk about it with reference to efficiency. Now, efficient power per single turbine is what matters the most. Per single turbine, not through the entire calculations. Wait a second. Through the entire turbine. So I know I can say that 0.45, that was the, like, basically the total power PE. Why do they give us so less space, man? 0.45 multiplied by 0.6 multiplied by A multiplied by U cube. That's what we initially calculated, right? And we had an answer of 96,761 kilowatt. Now, the maximum power output should be multiplied by 12 because this output was of one turbine. So we should multiply 96,761 with 12 and we get an answer of, in kilowatts, we'll get 96,761 divided by 12. We get an answer of 11, 6, 1132. So that is basically 1,161,132 kilowatt of total energy. Total energy. So we are done with this one. Consider the sustainability features of the planned wind farm. Now, talking about sustainability, look, the good thing is that since it's in a restricted area, so there are no carbon emissions. I'm sorry, I won't be able to write all of this down, so you just have to understand it. So you have to and consider the idea of carbon emissions. So direct carbon emissions are roughly zero because it produces clean electricity during operation, it reduces the reliance on fossil fuels. And another thing is that because turning the zones, it maintains 650 meters of spacing between towers. The open space beneath can still be utilized for agriculture, right? So it's actually occupying, it's cost effective and it's occupying the land potential. So you can use the upper region um, for the wind turbine and the lower region for agriculture and cattle grazing or whatever, solar panels or whatever. That's up to the person to decide. So that's the sustainability. Talking about the degree of our accuracy. Now, look, the 30 meters per second figure, it represents a high wind speed. In real life scenarios, the average speeds usually fluctuates. So the real world annual energy yield will be lower than this maximum rate. So what we calculated, this is going to be on the upper end because sometimes there is electricity shortage uh, in any even developing countries, let alone a country like Pakistan where I'm from, right? In any country, there could be sometimes electricity shortage, sometimes whatever would be the reason. So these can be the problems. All right. Oh, difficult paper, lengthy paper, extremely lengthy paper, mentally exhausting paper. We had to solve one question of circle theorems. Okay, let's solve this question. First, let me just color this in pink. Oops, no, this won't work. Or any color so that it at least, because this is going to make it too difficult for the students to understand. Why? Okay, just leave it at this point. Okay, so I know, first things first, from where should we start? The angle BOC, let's start from angle BOC. I'm always worried about not starting or stopping the recording. Now the angle BOC, as we know, both of these two angles are supposed to add up to 180 degrees. So BOC should be 180 minus 116, that should be 64 degrees, as it has been mentioned above. If that angle is 64, I know that, um, hmm, wait. Now you see, there is an imaginary chord here. So we know that, for instance, I explained this in circle theorems, that if we have two separate angles being created and that are stemming from the same chord, like this, both of those angles are going to be numerically equal. So what does it apply? It applies here. This angle ADE would be 28 degrees. Alright? This is a very pathetic thing that sometimes the examiners do to just confuse the students. They don't show you the imaginary chord. This is 28. And then what? Look, this angle is 64 degrees as well. And um, it's even taking me a lot of time, man. Shouldn't. Let's try to dissect it further. BOC and 28 degrees, if added together, this will give you 92 degrees. So BFC equals 92 degrees. Okay? And since um, in this case, no, it's not an isosceles triangle. How many marks is this question? I think it reached 5 or 6, 7 marks. Okay. DAC is angle subtended at the circumference, and angle subtended at the circumference is half than the angle subtended at the center. So DAC should be 116 divided by 2, which is 58 degrees. Okay. How many angles are available? Only one. Last one. AEC. Um, this angle is 58 degrees, so this is supposed to be 90 degrees entirely. This is 58 degrees, right? The entirety of this should be 90 degrees, so that's remaining 32 degrees. Okay? If this was given as 32 and this was given as 28, like this is basically 90 degrees, this is 28 degrees. So 90 plus 28 is 118 degrees. So AEC should be 180 minus 118, which is 62 degrees. So here we go. We're done with yet another filter. Like and subscribe for more.